Good morning, dear students. My name is Ferhan Mazher, and today is 9th of October 2021. And right now, I am with the 9 Matric class. The subject we are studying is physics, and we are on the chapter number 3. The name of the chapter is dynamics. And in this session, in this video, we are going to attempt the numericals, the word problems related with the dynamics, which are given in the review exercise of that chapter. And so let's start. We are talking about the numericals. So let's start. And the first numerical is coming up on the screen. So here we go. The first numerical number 3.1. This is the word problem or story sum, you can say. A force of 20 Newton moves a body with an acceleration of 2 meters square. What is its mass? You know, according to Newton's second law, a very famous mathematical equation of the Newton's second law of motion, F equals to ma. F equals to ma. So you know the force, that's 20 Newton. You know the acceleration produced, that is 2 meters per second square, and the mass is question. So we will write that equation, F is equals to ma, and in that equation, F is 20 Newton, A is 2 meters per second square, and M is the question. So you can see here we have put those values, 20, and here I have substituted A with the 2. So this 2 will go to the other side. Here it is multiplying with the M. When it will go to the other side, it will divide. So you will have M equals to 20 divided by 2. So M will be 10 kg. So that is the numerical 3.1. The question was, what's the mass? That's 10 kg, and you can see the answer is 10 kg. I hope that you have understood this numerical. Okay. So numerical number 3.2, the statement is the weight of a body is 147 Newton. What is its mass? Take the value of the of G as 10 meter per second square. So the weight of the body is given, that's 147 Newton. The mass is question. The G is 10 meter per second square. You know the formula, famous formula for the weight of the body is W is equals to mg. W equals to mg. So if you know the W, and that's 147, the G, the gravitation acceleration due to the gravity, that's 10 meter per second square. We can find the M. So you can see I've substituted these values here. This 10 multiplying with M, it will go to the other side. It will divide there. So M is equals to 147 divided by 10. So M will be 14.7 kg. So M will be 14.7 kg. So very simple and easy question. Hope you understood this. So that was 3.2. So let's move to the next numerical. The next numerical is question number 3.3. He says, how much force is needed to prevent a body of mass 10 kg from falling? So if the body is falling, you have to apply a force in the upward direction, and that force should be equal to the weight of the body. So if the body is falling, you have to at least apply a force in upward direction, which is equal to the weight of the body, and that will prevent that body from falling down. So you know that the force need to apply should be equal to the weight, and you know the weight is equal to mg. So F is equal to mg. So M is 10 kg and the G is 10. We know that the G value is 10 Newton per kg, and so it will be 100 Newton. So 10 multiplied 10, that will be 100 Newton. So this much force needed to be applied on a body from preventing it from falling. Hopefully you have understood this question. This was the question 3.3 from the chapter number 3. The name of the chapter is dynamics. The class is 9 Matric. Okay, so the next question coming up on your screen, that's question number 3.4. He says, find the acceleration produced by a force of 100 Newton in a mass of 50 kg. So we have to find out the acceleration. The A needs to be find out. The force you applied is 100 Newton and the mass is 50 kg. So if the applied force is 100 and there is no friction, so that force is the force which will produce the acceleration. So according to Newton's second law of motion, the mathematical form is F equals to ma, and so the resultant force is equals to the applied force. So F will be equals to 100 Newton, and the M is 50 kg. The A is question. Just substitute those values in that formula. So we will have 100 equals to 50 A. This 50 is multiplying with the A, so it will go to the other side, it will divide. So you will have A equals to 100 divided by 50, and so A will be equals to 2 meter per second square. 2 meter per second square. So that is the answer, and I hope that you understood that how we found the acceleration produced by this applied force. So that was question 3.4. Let's move to the next question. The next question coming up on your screen. Question number 3.5. He says, a body has weight 20 Newton. How much force is required to move it vertically upward with an acceleration of 2 meter per second square? Now you see, try to understand this concept. The body is supposed to move upward with 2 meter per second square acceleration. You see the force which you will apply. That force needs to do two things. One, it has to overcome the weight of the body. It has to balance the weight of the body. The weight is acting downward, so the applied force needs to balance the force. It counter the weight, sorry. And the second thing this force needs to do is to produce this acceleration. So in mathematical forms, I can tell you the resultant force which is needed, that must first of all, the applied force which you will provide, that needs to overcome the weight, plus that needs to provide the resultant force to produce this acceleration. So first of all, I will calculate that how much is the mass of the body, and then I will calculate how much force is required to produce the acceleration of 2 meter per second square in that body. And then I will calculate that how much the force should be applied. The applied force will be equal to the force needed to produce the acceleration plus the weight of the body. So first of all, you see in the steps, you can see this question. First of all, I will calculate what is the weight of the body. So W is equal to mg. The weight is given 20 Newton. The m I don't know, and the g value is 10. This 10 will go on the other side. It will divide. So m will be equals to 2 kg. So the mass of the body is 2 kg. Now the force needed to produce an acceleration of 2 meter per second square in the body of 2 kg. I can use the Newton's second law of motion. F is equal to ma, so that force is F equals to ma. M is 2 kg and the A is 2 meter per second square. Just multiply them 4 Newton. So the force needed to produce the acceleration is 4 Newton, and the weight of the body is 20 Newton. So the force you need to apply should provide both these forces. So the applied force will be equal to the resultant force, which needs to provide the acceleration, plus the weight of the body. So the resultant force is 4 Newton plus the weight is 20 Newton. So the total force required will be 24 Newton. So that is the question number 3.5 from the chapter 3, dynamics, and I hope that you understand this concept. So let's move to the next question. So here we have. So this question especially requires you to remember that formula of the tension and the acceleration. And this case also, this is a special case. Two masses, 52 kg and 48 kg, are attached to the ends of a string that passes over a frictionless pulley. Find the tension in the string and acceleration in the bodies when both the masses are moving vertically. Okay, so here you can see that the larger mass M1, that's 52 kg, and this is the smaller mass M2, that is 48 kg. So obviously this whole system will go like this. This is the pulley, and they both are attached with the string. And obviously where the larger mass is, there the body will go down. In both the sides, the you know, the in both the sides, the acceleration will be same. In both the bodies, the acceleration will be same. They both will move with the same velocity. They both will move the same distance, and they both will move in the same time. So the question is, what is the tension? And you need to remember this formula. The formula for the tension when the two bodies are attached with each other through a string and they are hanging vertically. The formula is very simple: 2m1 m2 divided by m1 plus m2, the whole thing multiplied with the g. You simply need to put the values here, and 2 into 62 into 40 into 52 into 48 divided by 52 plus 48, and multiply the whole thing with the 10. So when you do this calculation, that will be 499200. This will be 100, and you multiply with the 10. Okay, so this whole thing is 49920 divided by 100. So that will be 499.20. This is approximately 500 newtons. So that is the answer here, you can see. So the key point here is you need to remember this formula. If this formula is in your mind, then it's like this. It's a piece of cake. Then the next question is, what's the acceleration produced in them? The acceleration formula is m1 minus m2 divided by m1 plus m2 into g. And just put the values of the m1, that's 52 minus 48 divided by 52 plus 48 into 10. So this will be 4 divided by 100 into 10, 40 by 100, that will be 0.4 meter per second square. So this is how you find the acceleration. And these questions are very famous questions. Many times they have came in the paper. The only trick here is you should know, because there are two cases of these two bodies attached with the string with each other. One is this one, in which the bodies are connected with each other through a pulley, and they are moving vertically. Both the bodies are moving vertically. In this case, you should remember the formula of the tension and the formula of the acceleration. So one similarity I can tell you in both the formulas of the tension and the acceleration. In the denominator, we have m1 plus m2. They both are multiplying with the g. But in the case of the tension, the formula is in the numerator we have 2m1 m2, and in the acceleration we have m1 minus m2. So you have to remember this formula. Then this is very easy. So this was the question 3.6. Hopefully you have understood, and hopefully you will remember my advice that you need to remember this formula. Never forget this thing. Okay, so the next question. So the question 3.7 is coming up on your screen. He says two masses, 26 kg and 24 kg, are attached to the ends of a string which passes over a frictionless pulley. 26 kg is lying over a smooth horizontal table. So this M2 is 26 kg, and 24 Newton mass is moving vertically downward. So here this M1, this is 24 kg, is moving vertically downward. Find the tension in the string and the acceleration in the bodies. Okay, so in this case, that is the case in your, this is an article in your chapter of dynamics. So remember you need to remember the formula of the tension and the acceleration. You see the tension here will be M1, M2 divided by M1 plus M2 into G, and the acceleration formula is M1 divided by M1 plus M2 into G. If you remember this formula, this is like this. And you need to remember that M1 is the mass which is hanging vertically. Okay, so here we will have 24. Just substitute those values, 24 plus 26 into 10. G value is 10. So you will have 24 divided by 50 into 10. So it will be 240 divided by 50. And that will be 4.8 meter per second square. So that's the acceleration you can see here. And for the tension, the formula is M1, M2 divided by M1 plus M2 into G. The M1 value is 24, M2 value is 26. And remember, in this formula, M1 is the body which is moving vertically, and M2 is the body which is on the horizontal table. Okay, so you just substituted those values here, M24 into 26 divided by 24 plus 26 into 10. So you will have 4240 divided by 50. That will give you 124.8 Newton. So the tension will be approximately 125 Newton. And that is right answer, sir. You see, the question number 3.6 and question number 3.7, there are two numericals in the exercise, and there are two examples in the book. And so total there are 4 numericals on these 2 articles. You should all the time remember the formula for the tension and acceleration in the bodies, which are both bodies are moving vertically. And you should remember the formula of tension and acceleration for the 2 bodies, which are, one of them is moving horizontally and one of them is moving vertically. If you remember the formula of the tension and acceleration, then it's a piece of cake. So there are 4 questions, 2 in the as examples in your book, and 2 are in this exercise, which we have just done, 3.6 and 3.7, and they are very famous and they come in paper. Okay, so let's move to the next question. And the next question coming up on your screen. So you can see the next question coming up on your screen is, how much time is required to change 22 Newton second momentum by a force of 20 Newton? So how much time is required to change 20 Newton second momentum by a force of 20 Newton? You know, you have learned that the rate of change of momentum is equals to force. This is an article in your book. The rate of change of momentum is equals to force. It means the momentum, final momentum minus the initial momentum divided by time is equals to force. Final momentum minus the initial momentum divided by time is equals to force. So change in momentum is given, that is 22 Newtons Newton, and the force is 20 Newton, and the time is question. Okay, so we have written this formula here. The change in momentum divided by time is equals to the force. The rate of change of momentum is equals to force. Remember this sentence. And the change in momentum is 22 divided by time and equals to 20. So t will go to the other side. The 20 will come downstairs. So you have 22 divided by 20. T is equals to 22 divided by 20, and that will be 1.1 second. So the time required will be 1.1 seconds. So remember this formula. Never forget this, that the change in the momentum divided by time is equals to force. Or if you remember this, then there is no problem. That was the numerical number 3.8. Okay. Then he says, question number 3.9, how much is the force of friction between a wooden block of mass 5 kg and a horizontal marble floor? The coefficient of friction between the wood and the marble is 0.6. Okay, so we know the mass of the wooden block, and that is 5 kg. So from the mass, I can calculate the normal reaction of the surface. The normal reaction is equals to the weight. The normal reaction is represented with the R, and that is equals to the weight. The normal reaction is the reaction of the body to the weight of the surface to the weight of the block, and that is represented with the R, and that is equals to mg. And the coefficient of the friction between the wood and the marble is 0.6, and the force and the friction is the question. We know that the formula for the force of friction is equals to mu r, and mu is the coefficient of the friction, and the r is the normal reaction, which is equals to the weight, and that will be mg. So fs is equals to 0.6 multiply 5 multiply 10. The m value is 5 kg, and the small g is 10 Newton per kg. And you just multiply them, you get the 30 Newton. So the force of friction will be 30 Newton. That was the numerical 3.9 from the chapter number 3 of the 9 metric physics. Okay, so we are going to the next question, the question number 10, 3.10. These are the numericals coming from the review exercise of the chapter 3 of the 9 metric physics. How much centripetal force is needed to make a body of mass 0.5 kg to move in a circle of radius 50 centimeter with a speed of 3 meters per second? So the centripetal force is the question. The m of the body is 0.5 kg. The velocity with with which it is moving is 3 meters per second. The radius is 50 centimeter. I will convert that into meters. If you want to convert centimeter into meters, you will have to divide it with 100. So the radius will be equals to 50 divided by 100, and that will be 0.5 meter. You know the formula for the centripetal force is F equals to mv square divided by r. Remember, mv square divided by r. So the m, just substitute the value of the m, v, and r. So you will have 0.5 and into 3 square divided by 0.5. So it will be 0.5 multiply 9 divided by 0.5. So you will get the answer 9 Newton. Just enter these values in your calculator, you get the 9 Newton. So our answer is right, that is 9 Newton. So remember the formula, you need to remember the formula of the centripetal force. F equals to mv squared divided by r, where m is the mass, v is the velocity, r is the radius of that circle in which the body is rotating. So by this question, we have reached the end of this the numericals given in the review exercise. So my dear students, today we have done the numerical questions related with the chapter number 3. The name of the chapter is Dynamics. The course we are studying is 9 Matric Physics. This is the Punjab textbook board book, and this is the book which the Board of Intermediate and Secondary Education, Sargodha, has suggested our students to study. So I hope that this video will be helpful to you. If you find this video helpful to you, don't forget to subscribe to my channel and don't forget to like my videos. If you find this video useful, suggest these videos to your friends by sharing the link of this video in your Facebook and in your Instagrams. When you share my video, this gives me a lot of appreciation, and I feel motivated to make more videos on this. I hope that I have been to some help to you. So thank you very much, everybody. It was a great pleasure teaching you all. Thank you very much. Have a good day. God bless you all.